recapitulate what we have seen in the previous class. It is the lecture number 6 in unit number 1. Okay, so we have been discussing about conversions, binary number number conversions. Okay, so in the previous class what we have seen is that, so if you want to convert any number, for example, so normally we talked about what do you mean by a binary number system. I'm sorry, this is writing differently. Binary number system. What is binary number system is all about? It is completely depending upon what we have seen, zeros and ones. Only 2 digits that we normally talk about, and its relevant information also we have seen. Weights that we have seen. Okay, for example, 101011 is there. So instead of writing 2 power 0 its weight, directly we can write position 1 weight, second position, third, fourth, fifth, sixth positions are there. Okay, so depending upon its weights and its quotient, one quotient is there, we'll give you some value to that one. We can sum up all the things, we'll find its decimal value. Okay, and some names also, group of names also we have seen, group of bits that we have seen. We call it as some bytes. We use bytes is the name. Okay, bytes, nibble, these are the names that we normally used. Okay, so as I mentioned that these are called bits, we can call it as, these are all called bits. Binary digits are called bits. Now, and we have started off converting any number, sorry, binary number. Okay, so binary number to any radix, right? Any radix that we have seen. And similarly, we have also seen that any radix to decimal, sorry, binary. So this is what very important to note that. Okay, previously we have seen that any radix to decimal, decimal to any radix that we have seen, because we are familiar with the decimal number system. But computers are computer uses the binary number system. Digital computers uses the binary number system. That's why we should know the basics about the binary number system. Okay, so let us quickly move on to how do we do this conversion. For an example, we take binary to any number, any radix. For example, 2 methods are there. One method is that, as we know that, first method is conventional. What is this conventional method? Conventional method is, for example, 10110 is there, of base 2 is there. If you want to convert it into radix 4, for example, radix 4, what I have to do then? I have to, first of all, I have to get this from this 1 to decimal that I have to get, decimal, base 10, I need to convert it. Okay, so from the base 10, from this base 10, I have to convert it to, again, required number system. That's what we have to do. Okay, so what is the quick value of this one? What is the quick method? Quick method is, for example, 10110 is there, no? Base 2, what is its position? 0, 1, 2, 3, 4. So what is this value then? 2 power 4. What is the first one is 2 power 4. 2 power 4 means 16, first one, plus 0, plus 2 2s are 4, plus 1, sorry, 2, plus 0. So this is what we can write. So 1 into 2 power 4 is 16 plus 0 into 2 power 3 is 0 plus 1 into 2 power square, that is 4. 1 into 2 power 1, that is 2, 0. So this becomes 10. So what is this value then? 16 for 2022. So it is 22. So this value becomes 22 base 10. So therefore, what is this value then? So how do we get this one? This is actually 22 base 10. So this is how the procedure I have done. Quick method I have used. Okay. Now so from 22, what I have to do, from 22 of 10, I need to convert it into radix 4. So what is this division method that we have? Sorry, yeah, division method we can use is 22 of 4. 5, 2 will be the remainder. So 4, 2 2s are 4. Sorry, 2 1 4 1s are 4. 1 is the remainder. So 4 zeros are 0. So what is this remainder? 1. So this value is 1 1 2 is in the radix 4. So this is how we have to do it. Are you agree with me what I'm doing? So in the conventional method, if you want to convert from binary to any radix, first binary is converted into decimal, from the decimal to any radix, the required radix. That's what we have to do. Similarly, let us consider in this way also. Any radix now. Any radix. Convert to binary. So again, we use the same conventional approach. So it's a conventional approach. Conventional method. So what I can do here in this method, so I have a 22, for example, sorry, I'm considering that 2 1 1 of base 4, I want to convert it into a radix 2. So what I have to do then again, so I have to convert this 2 1 1 of base 4 into base 10 convert cheyala. What is this value? So just for simple quick method, we can use the quick method. 2 1 1 of base 4. So what is its value? 0 position, 1 position, second position. So therefore 4 squares, 2 times of 4 power square. That's what the meaning. 1 time of 4 power 1 plus 1 time of 4 power 0. So what is this value?
Sir, 0 time of 4 power 0.
What you're getting?
Nothing, sir.
Yeah. 16 2s are how much? 32.
32.
Yeah, it's a 32, right?
Overall 37, sir.
What is, somewhere we did mistake here. 7 plus 4 plus 1 is equal to 22. 22 is right. 2 months in the 4 months. 4 zeros. So that's wrong. Yes, this is not. So this is actually 112, right? So that's it. This is 112. What I have written here. So this is the same number I want to do it, because for the verification also it could be easy for us. Okay, are you getting what I'm saying? Okay, this is
Yes.
112. So therefore this is 112. This is 0 1 2. So therefore what is happening here now? I want to
1 into 4 square plus.
Yeah, 1 into 4 square plus 1 into 4 power 1 plus 2 into 4 power 0. So what is this value then? 16 plus 4 plus 2 is equal to 22 of base 10. Yeah, we have done correctly. Now this 22 is, we need to convert it into, this 22 is converted into decimal. So 10, I'm sorry, base 2, right? We have to do with base 2. So 11s, 0, 2 5s, 1, 2 4s, sorry, 2 2s, 4, 1, 2 1s, 0, 2 zeros, 1. So therefore, from bottom to top, this value becomes 22 of base 10 is equal to 10110 will be the radix 2. Is it clear? So these fundamentals you should know very well, first of all. Okay. You should know these fundamentals very well. So bind any binary to any radix to binary. So the conventional method follows, convert the binary number system into decimal, decimal to any radix. In the same way, any radix to decimal, decimal to required binary. Okay. So it's very difficult to do this kind of conventional method if the number of bits are increases or the number of digits in any radix is increases. Okay. So some approach is there. We will talk that approach now. Okay. So here, for example, ternary radix. So ternary radix in the sense radix 3 and radix 3. So quad radix, or I can say that it is simply radix 4. So radix 4. Something like this we can do, and octal number system. The octal number system, it is radix 8. Decimal number system means radix 10, and hexadecimal. What is its radix? 16. Okay. So now these are the different radix systems are there, usual radix systems considered. For example, we have a 0, we have 1, we have 2. Only these 3 digits I'm using. So then what is this radix? We can call it as radix 3. What we can call it as a radix 3 number system. Okay, so therefore, if this is the radix 3, R3. So please remember that R3 stands for radix 3. I'm writing in this way. Okay, so what is this binary equivalent for this binary? Binary equivalent of this one is, so that means any radix to binary convert cheyalante is just usual practice is this one. So 0 means only 0, it is valid bit here also. So both are valid bits only. 1 means is also valid, but in binary 2 cannot be transferred, but 2 can be converted into binary. How do we do this one? It's very simple method is that, so you take this one as a MSB bit and substitute this 0 as a LSB bit. Therefore 1 0 will be the octal is the ternary equivalent of 2. That means that this also we can do it, since we know that 2 of base 3 I want to convert into radix 2. How do I do this one? As we know that this will be converted into radix 10. What is radix 10? 2 into 3 power 0 only, that is equal to 2 only in the radix 10 also. So in the 2, how do I do this in binary number system? 2 multiplied by 2 divided by 2. 2 ones are 2, that is 0. 2 zeros are 0, remainder is 1. So from top to bottom, therefore 1 and 0 will be the base number 2, right? So the same thing only. But this is the logical way that we can mention in this method. Agreed? So one important point we have to remember is that, so here the minimum number of bits that are required, to code ternary, to code radix 3. How many minimum number of bits in also 2. 2, exactly. So I can write it here, the minimum number of bits, needed to code radix 3. Radix 3, the minimum number of binary digits, it's better to write bits anachu, binary digits so needed to code radix 3. And in 2, exactly. 2 bits are required. Fine, bond. Next, for example, I have 0, I have 1 here, I have 2 here, I have 3 here. So four digits are there. If you want to do it in binary, for example, so binary lo convert chedam anukuntanu, binary. So it is in actually radix 4 antam kada, as we know that radix 4 digits into radix 4. So in the radix 4, what is the value that we can get it here now? 0 is 0, possibility is there. 1 means one possibility is there, but 2 radix 2, sorry, radix 4 lo 2 digits ni ela represent cheyali manam. Take this one as MSP bit, yes. Take the first one is LSB bit, so take LSB is 1, and we have 3 also there, so again we have to take 1. Another possibility is that we have to take the next one 1. So I think it is better to try it here. So therefore, after 1 0 is completed, MSB bit becomes 1, and we have to use the LSB bit is again 0 and 1, right? So therefore, this is also the same way that we can do it. Whether it is true or false, also we can do it when the same procedure. We use the same procedure, right? You can get it there. So here also, okay. So దీన్ని ఏమంటామంటే సింపుల్ ఒక డెఫినేషన్ ఇద్దాం, ఇక్కడ మనం ఒక వర్డ్ ఇద్దాం. దిస్ ఇస్ కాల్డ్ బైనరీ కోడెడ్ ternary. Binary coded ternary andam. So binary coded ternary. So in the binary coded ternary, each digit in the radix 3 is represented by 2 bits in the binary number system. That's what we have to understand. Similarly here also, what is the how many minimum number of bits that are required to code radix 4 digits?
2, sir.
2 only. Here also the 2 only. Same thing is applicable here also. Therefore, I can simply write it is called binary coded quad. So it requires 2 digits or 2 bits. I can say that 2 bits to represent any digit in radix 4. It requires a minimum of, we need to write minimum, should not forget about it. Minimum. Maximum can be anything. So can I write, suppose for example, something like this, 0 0 0 0, something like this. Is it equivalent to 3 or not? Yeah, left hand side, how many zeros if you put does not affect the number. If you put zeros at right hand side, for example, and it has some values. Simple basics of the mathematics. So therefore it doesn't matter. So that is the reason why minimum is 2 bits are sufficient. Maximum can be anything. It doesn't matter. Okay, so far so good. Now let us write. So binary coded quad is over. Now let us consider another one, very, very important one. So it's for 0, 1, 2, 3, 4, 5, 6, 7. For example, 7 digits I'm using. So what is this radix? Can anybody guess? Radix 8. Radix 8 only. So I want to convert it into binary. So what is this logic here? Binary has got two digits only. Therefore 0 is the 1 digit. Okay. 1 is 1 digit. So I don't find any problem for 0 of octal to binary of 0. 1 of octal of binary of 1. Okay, fine. But 2 is a problem. So how do I get the next number? Just I have to use 1 here and 0 at this place. At 0 at this place, right? So this 0 I have to place it there. And for this one, 1, and I have to use this one. 1. That's it. What about 4? 4 for this one, I have to take this number. So therefore, this is called 1, 0. That is what is the value that binary number system we started with? 0. Therefore, that is what? 1, 0. And I need to talk about this is 0. Next one is again 1, 0 undalsinde. Compulsory we have 1, 0. And there is another possibility is that 1. Ante kada. So bit by bit we are introducing. So therefore this is also completed for this 1, 0, 0, 1 possibility, 1 is one other possibility. Now we have to go to this possibility. So here also what we can do it 1, 1,
1, 0.
Yeah, exactly. It is 0 and this is 1, 1, 1, 1, 1.
1.
Yeah. So whether it is true or false, how could you do it? So earlier procedure that we have to do it. So convert this one into decimal, decimal to binary. We can do it there. So therefore, what we can conclude here is that the minimum number of, what we can say that the minimum number of bits required for radix 8 is 3 digits, right? 3 bits. 3 bits are required. 3 bits are required. So therefore, that is the usual practice is that is the reason why usual practice is 3 bits covered. Then 0, 0, 0 and rastam. Then 0, 0, 1 and rastam. It doesn't matter how many digits that we put it zeros at the left hand side, right? 0, 1, 0, 0, 1, 1, 1, 0, 0. Already which is 3 bits. 0, 0, 1, 1, 1, 0, 1, 1, 1. Agreed? So
Yes,
therefore, if you want to code any octal digit, minimum 3 bits are required. Minimum 3 bits are required. So therefore, it is called binary coded octal. This is called binary coded octal. Okay. Next, we'll do the last another one. So radix 10 we consider radix 10. Okay, we have radix 10 means how many digits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 work on time. Yes. What is the binary equivalent? What is this binary? Same procedure.
0.
Yeah, that is 0, 1.
Next one.
1, 0, 1, 1. Next 1, 0, 0 will be the come. 1, 0, 1 will come. Next 1,
1, 0.
1, 1, 0,
1, 1, 1.
1. Next will come this one, right?
1, 0, 0, 0.
Yeah, exactly. 1, 0, 0, 0, 1, 0, 0, 1.
0, 1.
Yeah, that's. So therefore, can you define what is the minimum number of bits that are required to code one digit? 4 bits. So therefore, minimum bits are equal to 4. Right? So that's how we can write it. So therefore, instead of saying this usual practice, మనం ఏం చేస్తాం బాబు డెసిమల్ అనగానే ఇట్లా రాసేస్తాం 4 digits డైరెక్ట్ రాసేసుకుంటాం 0 0 0 0 0 1 0 0 1 0 0 0 1 1 0 1 double 0 0 1 0 1 0 1 1 0 0 1 1 1 ఇక్కడ తిరిగి 4 digits వచ్చేసినాయి. We have already 4 digits in it. That is it clear to all of you? So this is called very important, very popular mechanism. Word is called binary coded decimal. Binary coded decimal. This is called BCD. People will call it as BCD. Okay, na? Another important number system is there that is also it is necessary for us. It is necessary to remember, or it is necessary to understand. That is called octal. Sorry, hexadecimal. 16, radix 16. So therefore, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 రాదు కదా 10 అంటే ఏం చేస్తున్నాం మనం what we are doing A B C D E F. So these are 16 digits that we are using. So again, can we go for methodology in binary? How do we do it in binary?
0.
Yeah.
1.
So directly I can 0 radha 0 1 next 1 0
1 0 1 1
1
1 0 0
yeah 1 0 0
1 0 1 1 1 0 1 1 1
1 1 0 1 1 1 నెక్స్ట్ ఇది వస్తుంది నెక్స్ట్ అంతే కదా సారీ నాట్
No, sir. Fourth one. 1000.
యా 1000 1001 యా ఇక్కడ నుంచి మనం ఏం రాయాలి
1010.
యా 101
10.
తర్వాత మళ్ళీ 0 రాయాలి నెక్స్ట్ 101
1.
నెక్స్ట్
1110.
యా దిస్ ఇస్ 1100
00.
1101
1.
నెక్స్ట్
1110. 11.
So can you guess what is this minimum number of bits here also?
4.
4 only. So minimum number of bits is equal to 4. So therefore దీన్ని ఏమంటారంటే మనం binary coded hexadecimal. సో బైనరీ కోడెడ్ హెక్సాడెసిమల్ లో ఒక డిజిట్ ని ఎన్ని బిట్స్ కావాలంటే మీరు ఏం చెప్పాలి 4 bits యూస్ చేయాలని చెప్పాలి ఓకే సో దట్స్ వాట్ వెరీ ఇంపార్టెంట్ థింగ్ దట్ వీ హ్యావ్ టు రిమెంబర్ సో వన్ పాయింట్ ఐ విల్ రైట్ ఇట్ హియర్ ఫర్ ఎగ్జాంపుల్ 7 base 10 how many digits that I can use it here for decimal number system usually okay better first don't go for this one for example 231 of base 4 what is its value in radix 2 what is its value in radix 2 so conventional method we don't want to use it now it's very easy to understand so what I'm going to do each and every digit this is the one digit so sorry this is the one digit second digit third digit each and every digit in this one how many number of minimum bits are required in radix 4 in the radix 4 ఒక మినిమం డిజిట్స్ ఎన్ని కావాలి ఏ డిజిట్ అని రిప్రజెంట్ చేయడానికి ఎన్ని కావాలి మనకి మినిమం 2 డిజిట్స్ రిక్వైర్డ్ సో వాట్ ఇస్ ద 2 డిజిట్స్ హియర్ 1 అంటే ఏం రాస్తాం అందుకే మనం ఏం చేయాలంటే వెయిట్స్ రిమెంబర్ వీ హ్యావ్ టు రిమెంబర్ ద వెయిట్స్ ఫర్ ఎగ్జాంపుల్ సపోజ్ B5 B4 B3 B2 B1 B0 something like this a number I have given what is its weights we have to remember very weights here 1 weight 2 weight 4 weight 8 weight 16 weight 32 weight okay na remember that one these are the weights these are the quotient B0 B1 B2 B3 B5 are weights sorry coefficients these are all the weight values so therefore what I can do is that for example I want to total okay even kuda ekku avutadi kada better I will do it only restricted to 4 for example nenu 7 represent 6 represent cheddam anukondi for example I want to represent 6 here so what bits should be there in the given number 6 కావాలంటే ఏం కావాలి నాకు ఈ కోషెంట్ కావాలి దీని కోషెంట్ కావాలి am I right 4 plus 2 is 6 కదా so therefore B2 is what I can do it here 1 I can place it B1 I can place it 1 and B0 is equal to 0 so there is what is this value 6 only for example 2 I need for example I want 2 so what is this value that what bit is required middle bit is required other 2 bits are not required right for example 7 is required for me so what are the required bits ఏం కావాలి నాకు ఇక్కడ first bit required second bit is required third bit is also required 7 for example 1 is required which bits are required B bit is required I don't want to B2 and B1 and B0 B2 is not required right for example 4 bit తీసుకుందాం what is its weights in the case of 4 bits what is its weights 1 2 4 and 8 for example 12 I want to represent 12 I want to represent 12 represent చేయడానికి ఏ బిట్స్ కావాలి నాకు 8 weight కావాలి 4 weight కావాలి కదా so I need 4 weight and 8 weight and 4 weight so there I can place it here is the 1 and here is the 1 therefore remaining things are 0 this becomes 12 right so that means weights I need to concentrate on so that is the beauty of the binary number system we don't want bother about we need not multiply the things at the B0 B1 B2 B3 because already 1 into 1 1 అయితే 1 0 అయితే 0 తో multiply చేస్తాం but only thing is that we have to represent the weights for example 10 I want to mention what bits are required can anyone can tell 10 I need So what digits are, what bits are required? Which position bits are required? Where the logic 1 bits are required?
8 and 2, sir.
Hmm?
8
8,
and 2.
8 and 2. Remaining 2 bits are 0. Agreed? For example, 16 I need, sorry, 15 I need, 15. 15 I need. So what is the position that I want to get it here? 15 ante 8 plus 4 anta 12. 12, 13, 14,
All ones.
all ones undala. Adi very good. For example, 17 kaval naku. For example, 17 I need. Is it possible for 4 bits? No, if the 4 bits is not possible, what I have to do? I have to take 5 bits. That means 1, 2, 4, 8, 16 I need to remember. So that's the reason why weights we should remember. In the previous class, I told you that one. So we have to remember the weights of the positions for the binary number system. Okay. So the for 17 is required, means this one is required, MSB is required, here this is required, and this is required. Remaining all are zeros. Right? That's it. We have to remember in this way. Agreed? So this is what we have to remember. Some basics are required here. In this sense, for example, I have 4 bits, the radix 4 system I have given. What is its binary equivalent? What is its binary equivalent? Therefore, what we can say that each and every digit is represented by 2 binary digits, 2 binary bits, right? So how do we define the 1 here? Yes, 1 and tetra was in the 0, 1, sorry, 0, 1 kada?
Yes, sir.
What about 3?
1 0.
1 0.
3, please remember.
3 1 1, sir.
Yeah, 1 1, 1 1. What about 2?
1 0.
1 0. 1. You can. Okay, please mute yourself. Don't make noise. That's it. In base number 2. Is it clear to all of you? For example, 73210.11023 of base 8. I want to convert it into radix 2. Radix 2. So that means I have given the octal number system. I'm asking you to convert it into binary number system. Okay. Therefore, what I can do here now? So in a binary, in octal number system, each digit is represented by minimum of
4.
4. In octal number system, each digit is represented by minimum of
3 bits. 3 bits.
3 bits, not 4, it's 3 bits. So we have to take 3 bits. So therefore, this is the point is the right. This is called octal point. Okay. So from this left hand side integer, right hand side we can hold as a fraction. So we will write this left hand side first of all. Okay, 0 and 10 any bits vadal mano 3 bits vadal kada 0 0 0. Okay. Next 1 is there. So how do we do with the 1? 1 stands for
0 0 1.
0
0
0.
0.
Next 2 stands for
0 1 0.
0 1 0.
next 3 stands for
0 1 1.
0 1 1. 7 stands for 1 1 1. Then
Yes, sir.
a point here. Right hand side also we have to do. So on the right hand side, we should start from here. So we should start from here. Here onwards we should start. The left hand side, this one we should start from here onwards. Okay. So I can say that 0th position, it is minus 1th position. So the fractional side, what is the 1 value?
0 0 1.
Yeah, it is 0 0 1. What about the next one?
0 0 1.
0 0 1. What is the next one?
0 0 0.
0 0 0. What is the next one? 2.
0 1 0.
0 1 0. What is the next
0
one?
1 1.
0 1
1 1.
0 1 1. Is it clear to all of you? Is it simple? So that is the reason why we have mentioned that concept. So finding the minimum number of bits finding the minimum number of bits for a particular digit in that particular radix. Agreed? Okay. So therefore, whenever the moment, for example, I'm giving the moment something like this. Suppose 1, 1, 1, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0.001, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 1, 1. So I have given octal numbers, binary number system. I required octal number system. What is the octal value? What is my octal value?
So 8.
What we have to do is that, see, 8 lo kavali. So that means every digit in octal will represented by 3 bits, right? So first we have to concentrate it on integer.
We have to divide, sir.
Huh?
We have to divide the number in three bits.
Yeah, exactly. We have to separate, not division. We have to separate 3 bits, 3 bits, a group of 3 bits that we have to consider, right? So therefore, I'm going to consider these first. Whenever we have octal point, from that one onwards, we should start. So these 3 I can consider. What is this value? 0. Next, I'm going to consider these 3. What is this value? 1. Next, I'm going to consider these 3 digits. What is value? 2. So now I'm going to consider these 3 digits. This is 3. Now I'm going to consider these 3 digits. That is called 7. Similarly, we have to do it for another one also. Point. So we have to start from MSB to LSB, something like this. So for 3 digits, 1 I'm going to use. For 3 digits, I'm going to use 1. For 3 digits, I think better I can use a different color. So for 3 digits, I'm going to use this color. For 3 digits, I'm going to use, what is this one? 1 value, sorry, 2. So for these 3 right? So that's it. So this is how we have to represent, but because why we are doing this kind of things? Because mentioning some number in the decimal, in binary number system is a huge number. It's very difficult to communicate, or we are not able to communicate with the other human being about the decimal numbers, about the binary number system. Therefore, what we do is that we need to convert into somewhat reduced method, like octal number system. Octal is a very useful way. That means we are able to understand little bit comfortable when compared to the decimal number system. Sorry, binary number system. Okay. So more flexible is decimal. There is no doubt. For the humans, we are able to communicate with the numbers with the decimal number system. But systems, most of the cases, we want to talk about the systems with other fellows. We talk about in octal number system or hexadecimal number system. Okay. So anyway, fine. For example, I'm writing like this. For example, this is the number only I have given. For example, I want to convert it into hexadecimal number system. Binary number system octal lo kavali, the hexadecimal lo kavalani cheppanu. I need hexadecimal.
Minimum bits is 4.
Yeah, here I need to consider 4 bits. I have to take the combination of the 4 bits. So what I have to do it 1 1 1. Again I'm writing here 1 1 0 1 0 0 0 1 0 0 0.001 0 0 1 4 zeros 1 0 0 1 1. So what I have to do then? I have to take 4 digits. From here to here, I have to take 1 4 digit. From here to here, I have to take 4 digits. From here to here, I have to take 4 digits. What about last one is only 3 digits are there? What you
We can take 0 1 1 1.
Yeah, we can take it 0. No need to take that one. So we have to take 0. That's all. We can put 0. Okay, and take that is a 1 common point. Right? So therefore, this is called, what is the value of this one? Anyone guess? 1 0 0 0. You have to keep in your mind. Your mind look the 0 position, 1 position, 2 position. Sorry, 2 position. Sorry, I'm extremely sorry. This is not like that. This is the 1 value, weight value, 2 weight value, 4 weight value, 8 weight value. So only 8 is there, right? Right?
Yes, sir.
The next one is also 8, fortunately. What about the next one? ఇక్కడ 1 2 4 8 4 plus 2 6. What about this one? 1 2 4 8 4 plus 2 plus
7.
7. That's it. Quickly we have to do it. Similarly we do here also. From here onwards we have to start 4 zeros. From here onwards we have to start 4. We have to start 4 zeros. What about here now? Here also one pending on the kabatti we can put it 1 0 there at the point. For example,
Sir, we have to put it right side or the left side, sir?
we have to put it right side. We have to put it. In this case, for this case, but means on the fractional part, for a fractional part, we have to keep the things at the right hand side. Does not affect the value. Right hand side. Whereas it's very important for the integer part, so integer side, we have to keep at the left hand side. Right? That's what you need to remember. So now this is the value. So what is value again? 0 0 1 0.
6.
8.
Yeah, it's 8. 8. Hello, 8. So here also
One.
something.
Sir, 2, sir, 2.
Yeah, so 2. What about this value?
4.
So that is 0, sorry, 1 2 4 8. It is 1 2 4 8.
4.
1 2 4 8. 1 2 4 8. What is the value?
4 2 6.
4 2 6. That's it. Agreed? So this is how we have to do. So therefore this value is 7688.2426 of base 16. Is it clear to all of you? But care must be required when in any number, for example, 7321, for example, of base 10 is converted into base 2. Okay, but care must be required. Okay, why? Because here also 4 bits are required here. So in this case, we don't have any problem. Okay, in this case, we don't have any problem. For example, 7A3D2 anankondi. So what is how do we represent this one? Is a 16-bit number system. So how do we represent again? Let us write here. What is value?
First, to value is 0 0 1 0.
For 7 we'll write first of all. What is the value? 0 1 1 1, right? What about A? A stands for 10, right? 10, how do we write? మనకు వెయిట్స్ తెలుసు 8 4 2 1 అనే వెయిట్ మనకు తెలుసు 10 రావాలంటే ఎక్కడ ఉండాలి? వేర్ వి
1 0
1 0 1 0.
యా 1 0 1 0. నెక్స్ట్ 3 we know very well.
0 0 1 1.
D stands for D ಅಂತ ಇದೆಯಾ?
13, sir.
B C D, right? 11 12 13.
1 1 1, sir. 1 1 1 1.
1 1
1 1.
0 1, sir. 1 1 0 1.
12 and yeah, 1 1 0 1.
Okay, sir.
1 1 0 1. So therefore 8 plus 4 12. Last one is 13. Yes, fine. What about 2? 2 we know very well. 0 1 0.
0.
That's it. Binary number system. But only this point is we have to remember decimal to binary number system. Decimal to binary number system. Care is required. Care is required. So we talk about this one for after some time. Okay. Care is required. For any other number system, we don't have any problem. Okay. So is it clear to all of you? So finding the minimum number of digits for a particular radix and use those many number of bits to complete the number. Okay. Shall we do some exercise problems? Okay, we have another 5 minutes are there. We'll do an exercise problem.
Yes, sir.
We will go to, yeah. So what is the exact number of bytes in a system that contains 32 kilobytes? So 32 kilobytes they have given. What is this exact bytes? Another point. What we have to do? So 32 is multiplied with kilo means 2 power 10, right? So therefore, what to multiply this? So use the calculator and multiply this one, these many number of bytes that you can see. Nothing more than that. Okay. These many number of bytes. For example, number of bits are uncountable. Then what we have to do? This value is multiplied with byte means 8 bits.
8.
That's it. So similar examples are there. You can go through it again. Another important question from this one is, so convert hexadecimal 643 CD to binary and octal. See, 64 CD of octal into binary. How do you do this one? Exercise problem. For 4 bits are required since it is an hexadecimal. 4 bits are required. So therefore 6 means 0, 1, 1, 0. 4 means 0, 1, 0, 0. C stands for C and 12 kada.
12.
12 means 1, 1, 0, 0. D stands for 0, 1. That's it. This is called base. So and also they have asked what is its octal also. They have octal. Octal number system they have asked. Can anyone tell me how do we do this one?
We can three numbers common, sir.
Yeah, what we have to do it instead of going 16 to decimal to octal, what we have to do it first we have to convert it into binary. Binary is very easy for us to do it, right? And from binary just to combine 3 bits. Combine 3 bits. These are the 3 bit, 1 3 bit. Okay, this is another 3 bits. This is another 3 bits. Combine these 3 bits and these 3 bits. But last one, we can see that only 0. So put 0, 0 and combine those things also. Okay, the number is not changing. So what is this first number? 0. What is the second number? Yes?
6.
Huh? 6.
6.
What is the next one?
2.
4.
Next to?
3.
3. Next to?
1.
Next to?
5.
That's it. Is it clear? So which one is the fastest method? Converting from hexadecimal to decimal, from decimal to octal is easy, or converting from hexadecimal
Binary is easy, sir.
binary to octal. Binary's conversion is very easy, right? That is the one question they have asked. So this is the first question. First question, second question. So we'll do it another problems also. From each and exercise, multiple questions are there. I will concentrate on only 1 or 2 questions. Okay. Convert the following binary numbers to hexadecimal and to a decimal. Hexadecimal to decimal and this one. So okay, it's very interesting. 1.110. 1.110. So this is the one question they have given. So this is a binary. So convert the following binary numbers to hexadecimal and decimal. So what is its value in hexadecimal? What is its value in decimal? That is asked. How do we do this one? So in hexadecimal, what we have to do is 4 digits are required. So 1 is available. Okay, we don't have any problem with the 1. At the left hand side, I'm talking about 1. So remaining must be
0.
0. So only we have to keep it. So remainings are 0, 0, 0, and it keep point. Remain
1 0 0 1.
1 0. So now what is this?
0 0 0 0.
Yeah, it is 1 point. So this is the 4, right? This is the 4, and of course we have to keep this is also 4 zeros. So what is the value then? 9, right?
9.
9 0.
9 0. So it is in hexadecimal. What about the decimal? So decimal digits are also available here. Am I right? Decimal digits are also available here. So we can do it like this, or otherwise directly we can go for. So what we have to do it 1 into 10 to the power of. Sorry, I'm extremely sorry for decimal kada. 1 into 2 power of 0 point so plus 1 into 2 power of -1 plus 0 into 2 power of -2 plus 0 into 2 power of -3 plus 1 into 2 power of -4 plus 0 into 2 power of -5. So I told you that please remember these weights. So remember these weights and do the calculation. Of course, calculator is also there. You can do it there. So this is the 4th problem. So any other problem quickly let us look at. decimal. Okay, BCD. So that's it. The very important questions are there in the textbook. Nothing else. Remaining are other concepts only. Okay, fine. So far, so good. So this is how we have to do the number systems. We talked about the number systems. The two binary number system we focused on, and whenever we do the manipulations like addition, subtraction, multiplication, what concepts are there that we will look at in the next class. Okay, so concept wise, the problems we are clearing all the problems. Please try to go through it once and twice. Okay, we'll stop it here today. If you have any doubt, please send me a message through the modules. So inform your all classmates to come to the class.